20.4. Use Venn diagrams to classify two-dimensional figures. I can compare and classify two-dimensional figures using Venn diagrams. Spark your learning. A mosaic is a piece of artwork made with glass, stone, or ceramic tiles. Mosaic tiles come in many shapes. Draw a Venn diagram to represent the relationships among these polygons. Explain your diagram. Okay, so before we did our diagram, we had kind of the circles overlapping, right? Okay, in this case, we're going to nestle like circles inside of each other. Okay, so and then we're going to have different labels for those circles. Okay, so what I want you to do is we're going to draw one big circle. Okay, then inside of that circle, we're going to draw another circle. And then inside of that circle, we're going to draw another little circle. Okay, so the small circle, you need to decide what it's going to represent. Then we'll say what the second circle represents and then what the third circle represents. So basically, all of these shapes are known as what? Polygons, right? Okay, so the overall thing for this circle, or these circles all together, these are all polygons. So they're all some kind of shape, right? Okay, now, what do we notice about some of these? They have congruent sides, some of them have right angles, okay? So, what is one of those shapes that has only one thing? Look at this one. It has all what? Right angles and all the sides are congruent. Okay, so the small circle, we're going to say all sides congruent. Okay, once again, I'm not going to make you redraw the shapes, so we're going to number these as 1, 2, 3, 4, 5, and 6. So which one would go in the small circle? 5, because it's the only one with all the sides congruent. So basically, we're going to probably focus on the what? The sides, right? Okay, so middle circle. Okay, what's another label we could come up with about the side? Can we say 2 or more pairs of congruent sides? No, we're talking about the length, guys. Okay, so 2 or more. Congruent sides. So what would fit in there? Two and 4. So number 2 and 4. Okay, and then the large one would be what? 1 or more pairs, right? Large circle. 1 pair of congruent sides. We'll just go with 1. Okay, so what would go out? What would go in the big? Number 1, right? Okay, now we did not use what? 3 or 6 because they have what? No pairs of congruent sides. So 3 and 6 would come out here because they don't have any pairs of congruent sides. So basically what we're doing is we're trying to figure out something that these things share in common that we can use as our basis, right? Or what could be our commonality of our circles. So understanding number 1, Lila is designing a video game in which the players arrange quadrilaterals. She defines a trapezoid as having exactly 1 pair of parallel sides. Complete the Venn diagram to show how squares, rectangles, and rhombuses are related to parallelograms and trapezoids. label your figure. Okay, so they want to know the difference between parallelograms and trapezoids. So what would be the title of this one? Parallelograms or trapezoids? The first one would be trapezoids, right? Okay, and then this one would be parallelograms. And then both of those are types of what? Quadrilaterals. That's why they give us that header, right? Okay. So a trapezoid looks like what?
It's this
one pair of parallel sides, right? Oh. Okay, kind of something like that, right? That's not very good. Okay, so something kind of like that, right? Okay, so that's what a trapezoid looks like. Okay, what parallelograms? So what is something that can be two other things? A square. So that's probably going to go into our overlapping part, right? And then we're going to show that all the sides are equal, right? And then this is the square. Okay, so a square could be a what? A rectangle. And then this is congruent, and then these are congruent. And this is the rectangle. And then we also said the rhombus, right? And basically it's just a square turned on its side. Oops, I didn't spell rhombus right. Okay, and then what else is a parallelogram that does not fall in? What's the picture of a parallelogram? It's kind of like this, right? It has two slanted sides. And then these are congruent and these are congruent, right? Okay. So letter B, explain how the diagram would change when a trapezoid is defined as a quadrilateral having at least one pair of parallel sides. Then, so on the other side, we did the one or two, right? Okay. So if we did that together, could these somewhat overlap a little bit more? Yes. Okay. The trapezoid and the parallelogram could actually be in the same bubble, right? But would these all be on their own? Yes, those would still be on their own. Kitchen. Step it out. Number 2, Venn diagrams can be used to sort two-dimensional figures by their shared attributes. Sort the polygons into the diagram based on the categories labeled for each circle. So once again, we're going to number these because I'm not going to make you guys redraw. 1, 2, 3, 4, 5, 6, 7. Okay? Classify the figures. Identify whether the figure shares all 3 attributes. Draw it in the middle section where all 3 circles intersect. So is there a regular polygon? So regular polygons what? Have all the same length of sides, angles, things like that, right? Parallel sides. Okay, because there's something that has parallel sides on it, and there's a shape that has obtuse angles. Is there any shape up there that can hit all 3 of those things? Yep, which one? Number 5. So number 5 we're going to put here in the middle. Okay, then are there any shares 2 attributes? Draw it in section. Okay, so is there anything that has a regular polygon, so all equal length of sides, and then parallel sides? 6. Okay. How about a regular polygon, so all the same length of sides and an obtuse angle? 2. And then one that has parallel sides and an obtuse angle. Is there anything that goes there? No. Okay. Here's only one attribute. Draw that in the larger section, or we're going to write it. Okay. So a regular polygon still has all equal length. We already did 6. 1. Right? Okay. What about parallel sides? 4. Obtuse angle? 3. And then we're left with 7, and that is because it has what? A right angle. And it doesn't have any of those attributes, right? But it does have a right angle. Second example, number 1. Randy made a Venn diagram where a circle representing rhombuses is inside a circle representing trapezoids. What other figures belong in the circle with the trapezoid? Okay, so if the rhombuses can go in there with the trapezoids, then the trapezoids have to have at least what? What is the rule for a trapezoid? It has at least one pair of parallel sides, right? Okay, so what else has at least one pair of parallel sides? Square. What else? A rectangle. Well, they already said the rhombus goes in there. A rectangle. Okay, well, guys already seen rhombuses and trapezoids go in there, right? And then a parallelogram. We will start recording this page, and then if time runs out, the whole page does need to be finished. On your own, number 2, use structure. Gina is using blocks that are squares and trapezoids to build a bridge. Her teacher comments that she likes how Gina is using all trapezoids to build her bridge. Explain what definition the teacher is using to define a trapezoid. A square is a parallelogram with 2 pairs of congruent sides. Therefore, the teacher's definition must include 1 pair of parallel sides. Okay, so that's what we came up with for what the teacher must have thought. Reason, write always, sometimes, or never to complete the statement given by the definition of a trapezoid represented in the Venn diagram. So trapezoids are
Never.
Are what?
Never.
Guys, quadrilaterals are up here, trapezoids are here, and parallelograms are here. So basically, they're saying that these must have to have at least 1 pair of parallel sides. Does a rhombus have at least 1 pair of parallel sides? Yes, but it's not inside the parallelograms one, so it would be sometimes. Parallelograms are what? It's inside that other bubble, so it would mean always. Number 5, use tools. Desi makes this Venn diagram to show how polygons are related. Label the circles for polygons, isosceles triangles, and regular polygons. Okay, so quadrilaterals and triangles are all what? They can all be parallelograms, right? Okay, where would isosceles triangles go? Under the triangles, right? Oh, I forgot that. And then we have regular polygons. So did we use everything they wanted us to label? Okay, then they want us to draw a square, a regular pentagon, right isosceles triangle, equilateral triangle, and a rhombus. Okay, I'm not going to make you guys draw it. We're going to number these again. So square we're going to say is a 1, rectangle, irregular pentagon is a 2, right isosceles triangle is a 3.